Still wearing the same tighty-whities you grew up with? Duluth Buck Naked is getting people across the country to change their underwear. With no pinch, no stink, and no sweat, Duluth Buck Naked underwear feels like you're wearing no underwear at all. Plus, they're treated to fight odor, helping you to stay fresh all day long. Still not convinced it's time to change your underwear? Shop Buck Naked at Duluth Trading Company.
Simply Safe was named the best home security of 2023 by U.S. News and World Report. But we don't do what we do for the accolades. We do it to protect you and everything you love. Our advanced sensors and HD cameras are powered by 24/7 professional monitoring for fast emergency response. Visit simplysafe.com/Spotify to get 50% off any new system today. Advanced home security, 24/7 professional monitoring for less than $1 a day. There's no safe like Simply Safe.
This is SpaceTime Series 25, Episode 25, for broadcast on the 28th of February 2022. Coming up on SpaceTime, astronomers identify stellar streams belonging to 6 dwarf galaxies cannibalised by the Milky Way, a new study examining the chemical composition of the galaxy. And China says that spent rocket stage, destined to crash on the far side of the moon this week, isn't theirs. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New observations from the latest data released by the European Space Agency's Gaia mission have allowed astronomers to identify stellar streams belonging to 6 dwarf galaxies, which have all been cannibalised and torn apart and eventually merged into the Milky Way over the past few billion years. The findings, reported in the Astrophysical Journal, include a previously unknown dwarf galaxy, which has been named Pontus. Whereas earlier studies have reconstructed these mergers by hand, this new work applied a systematic statistical evaluation of 257 stellar streams, globular clusters, and satellite galaxies using the Gaia data. The results are an important step towards a more complete reconstruction of our galaxy's history. The Milky Way that we see today is thought to have been formed through the merger of 9 or 10 smaller satellite galaxies. And there are at least 4 galactic mergers which are underway today, with tidal streams drawing stars and gas from both the large and small Magellanic Clouds, as well as the Sagittarius Dwarf Galaxy and the Canis Major Dwarf Galaxy, and they're just the ones we know of. Artists' impressions of our home, the Milky Way Galaxy, makes it look like a brilliant disk of stars, some of which are in swirling spiral arms. Less conspicuous, but just as interesting, is our galaxy's stellar halo, a vast spherical region of stars which envelops the entire galactic disk and surrounding regions. The current picture of the formation and evolution of the Milky Way indicates the halo contains the oldest stars in the galaxy. That makes the stellar halo something of an archive of our galaxy's interactions with its surroundings. Every so often, a small galaxy will come so close to the Milky Way that our home galaxy's gravity will capture it. Now, our galaxy's gravity will act more strongly on those parts of another galaxy that are nearest to us, and it acts more weakly on those parts that are further away, so that parts of a captured galaxy will typically be drawn out into a longish trail of stars and gas known as a stellar stream. The stellar stream will then continue orbiting the halo, with the stars becoming more and more dispersed within the halo over billions of years. And of course, other components of smaller galaxies are likely to also be preserved in the halo. Now, the galactic halo contains lots of so-called globular clusters. These are compact spheres containing millions to billions of stars, mostly older stars, usually all born at around the same time, and strongly bound together by their mutual gravity. The Milky Way has about 150 of these globular clusters. Also, galaxies are typically orbited by even smaller satellite galaxies. The new study, led by Kalhati Malhan from the Max Planck Institute, is an ambitious attempt to bring data about stellar streams, globular clusters, and satellite galaxies all together to create a comprehensive merger atlas for the Milky Way. a sort of map showing which of these objects are remnants of specific mergers that our home galaxy has witnessed. The analysis is only possible because of the unique data set being made available through the third data release from the European Space Agency's Gaia mission. Launched in 2013 and with its first data release in September 2016, the Gaia mission has provided astrometric data on more than 1 billion stars, including exquisitely accurate locations, as well as information about changes in their position in the sky, a quantity known as proper motion. The Gaia mission is already responsible for doubling the number of known stellar streams from 25 to around 50. That's significant because stellar streams aren't visible in the night sky. Gaia's second data release tracked the movement of billions of stars across the sky, using the Doppler shift radial velocity method to determine if an object was blue shifted, that is moving towards you, or red shifted, that is moving away from you. And a group of stars all moving together in the same direction compared to background stars is a telltale sign of a stellar stream. The work by Malin and colleagues used the Gaia data not for separate stars, but instead for the stellar streams, globular clusters and satellite galaxies in the galactic halo itself. There are several ways of describing motion in a gravitational potential, but one special set of qualities, so-called action variables, proved to be especially suitable for this task. Similar to physical qualities like energy or angular momentum, which can be calculated from an object's motion, action variables are somewhat more abstract, but they do have some key advantages. As a smaller galaxy merges with the Milky Way, the action variable values for all of its components, that is, its stars, satellites, clusters, should all remain very similar throughout the merger. In turn, an analysis of action variable values provides information as to which objects were originally part of the same galaxy, and thus which were part of the same merger process. The authors computed the action variable values from the Gaia 3 data release for some 170 globular clusters, 41 stellar streams, and 46 satellite galaxies. Now, for 62 of these objects, their statistical analysis was able to assign them to some 6 different mergers, 5 of which had been previously known, namely Sagittarius, Cetus, the Gaia Sausage Enceladus, LMS-1 Wukong, and Arjuna Sequoia Litoi. And in the analysis, the researchers also discovered a merger that, until their work, had been completely unknown. They've named the merger and the galaxy that merged into the Milky Way Pontus. The small galaxy Pontus merged with the Milky Way, moving in the opposite direction to the Milky Way's rotation. But it was so slow, it was comparatively low in energy, which the authors say might be hinting at a very early date for this particular merger. The new analysis also provided new data about a previously known merger. It showed that 3 previously known stellar streams were all part of the same LMS-1 Wukong merger, which was discovered in 2020. Interestingly, they were also the most metal-poor star streams known. Astronomers refer to all elements other than hydrogen and helium as metals. If the progenitor galaxy contained very few metals or heavier elements, it's likely to have formed very early in cosmic history. The merger of this galaxy with the Milky Way, however, may have taken place considerably later in time. As for the remaining 195 objects, there are several possibilities. They may all have been part of much smaller galaxies that merged with the Milky Way, not leaving any larger groupings behind. Of course, they may also simply be hinting at the limitations of the methods astronomers are using. Notably, the authors found a candidate for a 7th merger by eye, inspecting their action variable diagram, while the automated search clearly overlooked that, as well as 2 other known mergers. What the present analysis does not yet permit is a reconstruction of the chain of events of the order in which the different mergers occurred. And this is what the researchers now hope to reconstruct as the next step by running simulations of how these mergers are likely to have taken place. If all goes well, the comparison between the simulations and the available data should allow for a reconstruction of exactly how the stellar halo of the Milky Way was built up over the past billions of years, one merger at a time. This report from ESA TV.
Rotating slowly 1.5 million kilometers from Earth, Gaia is scanning the entire Milky Way. Since 2014, the mission has been mapping the distance, position and movement of 1.7 billion stars to reveal our galaxy as never before.
The scientific impact of the mission already is immense. We see 3-4 papers appearing per day. We're touching virtually every area of astrophysics, from very fundamental predictions of 50 years ago to new things that you see and the dynamics and the history of our own galaxy.
Capturing 70 measurements of every star, Gaia produces vast amounts of data. At a meeting in Groningen in the Netherlands, scientists have been discussing the challenge of processing and visualizing this information.
Gaia is probably one of humanity's greatest missions, one of the greatest catalogs of data that has currently existed for humans to go through. And it's almost impossible to give you all of the ways in which Gaia is impacting astrophysics.
Earthbound observatories provide a snapshot of celestial objects in the night sky. But by measuring how the stars are moving and visualizing that data, astrophysicists are using Gaia to trace the history and evolution of the galaxy. They've discovered, for instance, that stars born together in star-forming factories move in clusters or families throughout most of their lives.
It is mind-blowing. I can't believe we can do this. I could never have dreamed that we could pull away from our position on the Earth and actually see the structure of these kinds of associations. And then you can run time forward and see exactly how they're moving. You can compare and contrast how they're all moving differently. And I think it's a story of vast proportions in our understanding of how stars form and evolve.
Other science teams have used Gaia data to confirm today's Milky Way is formed from giant galactic mergers.
So most of the stars in the Milky Way rotate like the sun in a clockwise sense. So for example, what we discovered is a very large group of stars that are going the other way around. And so that's already very suspicious, and it tells you kind of that these stars were formed elsewhere, being such a large group. And it's also very old stars, so that was already the first hint that actually one component of the galaxy is probably made up from stars born somewhere else.
Across Europe, hundreds of people work on the Gaia mission, ensuring the data is accessible to everyone. There are likely to be plenty more revelations to come.
Gaia is currently in an extension of the original 5-year mission. What we do is we gather more data, we get better statistics, and then we can derive more precise results.
Gaia is not only mapping the stars, it's giving us a new sense of our place in the universe.
And in that report from ESA TV, we heard from ESA Gaia mission manager Fred Janssen, American Museum of Natural History astrophysicist Jackie Fahey, and astrophysicist Amina Helmi from the University of Groningen. This is SpaceTime. Still to come, we continue our look at how the Milky Way was made, and China says the spent rocket stage destined to crash onto the far side of the moon on Thursday isn't theirs. All that and more still to come on SpaceTime.
Hey, I'm Ryan Reynolds, owner of Mint Mobile, with a message for everyone paying big wireless way too much. Please, for the love of everything good in this world, stop. With Mint, you can get premium wireless for just $15 a month. Of course, if you enjoy overpaying, no judgments, but that's weird. Okay, one judgment. Anyway, give it a try at mintmobile.com/switch.
New activation and upfront payment for 3-month plan required. Taxes and fees extra. Additional restrictions apply. See mintmobile.com for full terms.
Astronomers with the Galactic Archaeology with Hermes, or Gaia collaboration, have been studying the light from some 600,000 stars in order to get a better idea of the chemical composition of the Milky Way Galaxy. The findings, reported in the monthly notices of the Royal Astronomical Society, are providing new data on which stars originated in the Milky Way and which originated in other galaxies and were then cannibalised by the Milky Way over billions of years. The study's lead author, Sven Bude from Astro 3D at the Australian National University, says science still doesn't really understand how the Milky Way formed or evolved. Bude and colleagues began by analysing the light from stars in great detail. They did this using the High Efficiency and Resolution Multi-Element Spectrograph Instrument, or HERMES, which is attached to the 4-metre Anglo-Australian telescope at the Siding Spring Observatory in far western New South Wales. HERMES is designed to obtain the highest spectral resolution multidimensional datasets for more than 1 million stars of all ages and locations in the Milky Way. It works by splitting light from stars into a spectra, rainbows with bands at very specific wavelengths corresponding to specific elements and molecules. It's a unique barcode, providing astronomers with a star's chemical composition, temperature, and even whether it's travelling towards or away from you. By scanning these stellar barcodes, the authors were able to measure just how abundant 30 key elements, things like sodium, iron, magnesium, and manganese, were in each star, and also how they appeared in different concentrations depending on where the star was formed. The discovery is an early step towards reconstructing a picture of the early evolution of the Milky Way to get an idea of the size of galaxies that have been consumed in the process. Bude says it could also help scientists understand how several weird features of the Milky Way came into being. For example, one mystery the new observations could help resolve is why there appear to be two distinct populations of stars, one much older than the other, in the main galactic disk of the Milky Way. The older stars have moved, so they look like they've bulged out of the main plane of the Milky Way, while the younger stars form a much thinner band in the plane. These have become known as the thin and thick disks. Bude says astronomers don't know how these separate populations of stars formed, and the new findings of the remnants of gigantic galactic collisions may help resolve the issue.
The HERMES spectrograph is a high-efficiency and multi-object spectrograph. And although that sounds very technical, the idea behind this is that we can observe a lot of different stars at the same time, even 400 at the same time. And that allows us to take stellar spectra, so basically split the light of stars into its wavelengths and analyze that for millions of stars nowadays. And when we look at these stellar spectra, we can basically use them as kind of fingerprint of the chemical composition. There's like a stellar barcode. You see some bright and some dark patches in that, and that allows us to figure out the chemical composition of stars. And when we do that for 1 million stars, we can really try to figure out which stars look similar, which stars do not look similar, and then ask the question why. And for some of these stars, we have actually figured out they look very, very different to the stars that we typically see in the Milky Way, like our sun. And that is because they are not born in the Milky Way. They were born outside of the Milky Way and then have been basically eaten up together with the whole galaxy that they were part in some billion years ago.
So this lets you look at how the Milky Way's evolved through galactic cannibalism,
Exactly,
gobbling up stars from other galaxies.
Exactly, yeah, and that's something that happened a lot in the early Milky Way, basically in the youth of the Milky Way. But because that's so long ago, it's really hard to understand that by looking at the Milky Way today. So the great thing is that we can use these stars as kind of fossils because they capture the information from when they were born and preserve them over billions of years. And so basically by looking at how these stars look like now, we can reconstruct how the Milky Way must have like some 10 billion years ago.
And there are some mysteries you're hoping to solve with this too. The thin and thick disk.
Exactly, that is exactly right. And as you say, it's a mystery. So when you look at this band of stars that we see on the night sky from Australia or all over the world, we basically see that as one band. But if you look closer and if you do some counting of stars, you see that there's a weird bimodality. Basically, you see a lot of stars very close to the plane or the middle of this band, and then you see a lot of stars that are also further away. And if you basically try to make sense of that, you can say that some of these stars must be on a very thin disk and some of these stars must be on a thick disk. But we still try to understand why. And looking at the chemistry, we have now understood that, well, these stars must have formed at different times. The stars that are on this thick disk, must have formed quite early. So these are the very old stars that you mentioned. And then the young stars that are very close to the plane on the thin disk are the ones that are a bit younger. They are chemically more enriched, but we still are struggling to understand and reconstruct what causes these two different populations to form. So we believe that there must have been some massive event happening around 8 to 10 billion years ago. That's basically where we see a split in between these young and these old stars. And we still try to figure out if this is something that happens naturally over the evolution of a galaxy, or if that is, for example, something that happens if the Milky Way has eaten up a massive other galaxy and basically changed its shape completely around 8 to 10 billion years ago.
One of the other projects that can help you in this is Gaia, the European Space Agency mission. And Gaia's just returned its third data set, and the people who have been studying that, they've found what they think are probably at least 6 stellar streams in there, one new one, and they think there are probably 9 or 10 stellar streams in all, which means the Milky Way's had at least 9 or 10 encounters with other galaxies.
Absolutely, yeah. And the great thing is that the satellite that you talked about, it continues to measure. So the great thing is at the moment we can work with measurements of how stars move for roughly 6 million stars. But in the future, soon in June actually, we'll have 11 million stars or even 30 million stars that we can work with, where we have extremely good measurements of how these stars move. So that will make it possible for us to understand the movement of such stars or even populations of stars much better, and hopefully find even more than these 6, 7 streams or merger events or collision events. So there's much more to discover after June this year, and I'm really looking forward to that.
At the moment, if my calculations serve me correctly, we're in the process of merging with at least 4 galaxies. There's the Canis Major dwarf galaxy, there's Sagittarius dwarf, and of course the large and small Magellanic Clouds.
Yeah.
When I look at these, I notice that figure you mentioned earlier, 8 billion years ago, that seems to line up with one of the Sagittarius dwarf galaxies encounters through the disk of the Milky Way.
Yeah, so I think for the Sagittarius dwarf galaxy itself, we think that the last encounter, if I'm not correctly, was 500 million years ago.
Yeah.
I would have to double check the numbers. But yeah, we definitely also see signs of the Milky Way still warping because of that. So we definitely see that the Milky Way is what we call not an equilibrium. It's constantly evolving. And if you shoot something like a Sagittarius dwarf galaxy through the disk, yeah, we see the effects of that. And if you do that for a very young Milky Way that is a bit smaller, the effects will be even more drastic because the ratio of the two galaxies will be more similar. And if we think about this being like 9 or 10 billion years ago, it's really hard to imagine how that could have looked like. And that's why we're currently following that up with simulations, basically simulating a Milky Way and how it evolved and trying to figure out how that could have happened and what effects that would have on the evolution of the Milky Way up to the present day.
You were talking earlier about stellar barcodes in the spectra. There are certain chemicals you're specifically looking for, aren't there?
Yeah, those are really the elements that you could almost call them telltale elements because they tell us very different stories. And looking at, for example, sodium, that tells us a very different story of how such elements are enriched by galaxies or by dying stars that basically explode in these massive and energy-rich events called supernovae and release sodium to the surrounding medium. And then there's other elements, for example, like iron, that are born in slightly different environments that take, for example, lower mass stars that are exploding in less energetic events. And it's basically by looking at different elements, we get the whole mix, we get the full story. So looking at sodium and iron and, for example, magnesium, we really get the kind of enrichment story of our galaxy in full detail, but also we get the enrichment story of other galaxies because these other galaxies would have enriched these elements quite differently because they're, for example, less massive stars, so they can enrich some of these elements not as good. And that gives us a very different chemical fingerprint of the mass and the evolution of these galaxies.
At the moment, is Gaia primarily looking at stars in the disk of the Milky Way, or are you venturing further afield into the halo and towards the bulge?
We actually are trying to actively avoid the galactic plane where we see a lot of these stars because that's where we have a lot of dust. And dust is basically the enemy of any spectroscopist. Anybody who cares about starlight will have a hard time with dust because it basically absorbs the light, and the light of stars cannot reach us anymore. So what we actually do in Gaia is we look everywhere up in the plane. So that means we look at stars in the galactic halo that are not obscured by dust, and we find a lot of different things. So what we pride ourselves with is that we actually don't care necessarily what stars we look at, because then we get the full coverage of all the different stars that are out there. And we really find also the odd ones, which is another great thing, because especially from the weird or peculiar stars that we find in our galaxy, those are the ones where we can really figure out how stellar physics works, how chemical evolution works, how these weird chemical abundance patterns come about. And that's something that with Gaia, we find all of these strange stars or peculiar stars. So we really care about them, so to say.
Tell me about some of the strange ones you found.
We have found a lot of stars that, for example, have abundance patterns that the theoreticians cannot explain yet. So we have, for example, we find stars that have a lot of lithium. Lithium is one of the elements that we, for example, use for batteries and all of these sorts of interesting things on Earth. But in stars, they tell us also very, very complex and complicated history, because lithium is one of these elements that's typically very easily destroyed. So stars that live very long will typically have destroyed most of their lithium. But we find some stars that are very old have preserved the lithium. And not only that, they actually have more lithium than we would have expected for their age or for stars in general. And that's something that is really a big riddle that we try to figure out. Can, for example, stars create lithium by, for example, eating other planets, or by creating that in a different, what we call nucleosynthetic event? Like, can they basically, within their atmospheres, create lithium? And it's still puzzling. But Gaia has helped us to understand some of these problems, because we now have a data set of almost 1 million stellar measurements. And before Gaia started, we had 1,000 or 2,000. So we really have a much bigger coverage, and we can now narrow down what different types of stars have this lithium enrichment, and possibly narrow down what path could create lithium in such stars. But that's still to be found. We still are struggling to understand that. And there's a lot of different possibilities that we currently still have to understand.
That must be the sort of thing that excites you.
Oh, absolutely, yeah. Yeah, I think one of the most interesting things that with Gaia we have actually been able to do is we have measured lithium in these very old stars. And interestingly, there's a prediction from Big Bang Theory. So if you basically look at the early universe, you would not expect a lot of different elements to be created, mainly hydrogen and helium, and like a small amount of lithium. But measuring some of the oldest stars that we can see, we actually don't measure enough of this lithium. So basically the theory from cosmology predicts some amount of lithium, and we measure 3 times less. And we have for a really long time not understood why this could be. And now with the measurements from Gaia, we have possibly found a solution, and that is that most of these very old stars have depleted this lithium. They basically have burned it away to a factor 3 below what it was initially when the star was born. So there's a lot of interesting things coming out, or even of the observations we do, that I would have never predicted. And as we keep on going, I'm pretty sure there's going to be much more amazing stuff coming out of all of these measurements as well.
Are you finding many stars in intergalactic space, in the area between the galaxies, that you've been able to look at and evaluate and work out the composition?
Yeah, that's a really good question. So for our observations, we use the 4-meter telescope in Australia, and we typically don't observe stars that are very far away. Most of the stars that we observe, we are pretty sure are currently situated within the Milky Way. But by chance, because as I said, we don't really care about which stars we observe, we have also observed some stars that are in the Large and Small Magellanic Clouds. And we didn't really appreciate that. But interestingly, we have found that these stars have very different compositions, but we're still trying to analyze these stars. It's very complicated. These are very bright, very hot objects. And we're basically reaching the limits of what chemical information we can extract from them.
That's Sven Buda from the Australian Research Council's Centre of Excellence for All-Sky Astrophysics in 3 Dimensions and the Australian National University. And this is SpaceTime. Still to come, China says a spent rocket stage destined to crash onto the far side of the moon on Thursday isn't theirs. And later in the science report, A new study shows that elderly dog owners are 50% less likely to have a disability compared to non-dog owners. All that and more still to come on SpaceTime. China says a spent rocket stage destined to crash onto the far side of the moon on Thursday isn't theirs. The object was originally thought to be a SpaceX Falcon 9 upper stage booster, launched 7 years ago on NASA's Deep Space Climate Observatory satellite Discover. However, last week, the same scientists claimed a revision of their calculations showed the rocket was actually the booster for China's Chang'e 5T1 lunar exploration mission, which was launched back in 2014. But Beijing says no, it's not theirs. It claims it conscientiously upholds the long-term sustainability of activities in space. That's despite its decision to deliberately blow up a disused weather satellite in 2007, resulting in the biggest debris cloud of space junk ever seen orbiting our planet, and which is still posing a threat to space navigation today. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found that children produce far less aerosol particles in their breath when speaking and singing than adults do, and this consequently reduces their ability to pass on SARS-CoV-2 and other viruses. The findings, reported in the Journal of the Royal Society, are based on the measured emission rate of 15 pre-adolescent children at rest while speaking, while singing, and when shouting. And the figures were then compared to 15 adults under exactly the same conditions. The study found that the children's aerosol particle production was around 4 times lower than adults. The authors suggest that this new data could help supplement SARS-CoV-2 risk management scenarios for school and extracurricular activities. Almost 6 million people have now been killed by the COVID-19 coronavirus since it first spread out of Wuhan, China. However, the World Health Organization says the true death toll is likely to be double that amount, with some 450 million people now confirmed to have caught the virus. A new study has shown that untrained captive orangutans instinctively know that a blunt object is good for hitting things with, while a sharp object is good for cutting things. The findings, reported in the journal PLOS ONE, are based on a test where the orangutans were given both blunt and sharp stones. As the scientists watched, they found that orangutans who had not had any demonstration of tool use in the past instinctively would hit things with a blunt concrete hammer. And when given a puzzle box made of a silicon skin with food inside, one orangutan immediately grabbed a sharp flint stake to cut the skin in order to retrieve the food. The action represents the first demonstration of cutting behavior in an untrained and uneducated orangutan. Or forget what you may have heard in the tabloids. New research has confirmed earlier studies showing that consuming meat fewer than 6 times a week is linked to a lower cancer risk. The findings, reported in the peer-reviewed British Medical Journal, drew on data from nearly 500,000 people aged between 40 and 70. Scientists found that overall cancer risk was 14% lower among vegetarians and vegans compared to meat lovers who indulged more than 5 times a week. Researchers also found that male vegetarians and vegans had almost a third lower risk of prostate cancer than their meat-eating counterparts. A new study has found that elderly dog owners may be 50% less likely to have a disability compared to non-dog owners. The findings, reported in the journal PLOS ONE, looked at over 11,000 older Japanese adults. The researchers collected data on dog and cat ownership from people between the ages of 65 and 84, as well as gathering demographic, disability, and other health-related data from the participants. They found that current dog owners are roughly half as likely to have a disability compared to those who've never owned a dog, even after adjusting for other factors known to affect the risk of disability such as marital status, history of chronic diseases, and the time spent outdoors. It seems dog owners who exercise regularly had an even lower risk of disability. The researchers also found that cat ownership was not associated with any difference in disability risk. But then again, people don't actually own cats, do they? It's the cats that own the people. Okay, time for the silliest story of the week. And there are reports of a man claiming he's been stalked by a horrifying half-man, half-dog-like creature during his visits to a local fishing spot in the Australian outback. The man says his first encounter happened while kayaking in the area. And then during a second visit to the same area, I know I wouldn't have gone back, this dogman-like creature chased him, smashing trees out of the way as it ran after him. Why did he go back? Anyway, he says he was able to take a quick photo of the creature while being pursued, but all that's really visible is a blob and some shadow. The Dogman story follows claims by a so-called paranormal investigator in the United Kingdom who says he has video evidence of a strange Bigfoot-like creature crouching in the woods during a recent Sasquatch hunt. He claims the local area around Cannock Chase has been home to reports of a legendary Yeti-like creature ever since the 1800s. He says he and his friend initially heard some rustling in the dense woods, but thought it was probably just some small animals. However, when he got home and reviewed his film, he says he could clearly see the shape of a gorilla or Bigfoot-like creature hiding between the trees. And he says he was even able to make out one of the creature's knees, then an arm, and finally the creature's head and face. In reality, the film's a little more than 14 minutes of a man saying, "Did you see that?" and the other one saying, "No." Tim Mendham from Australian Skeptics says, "It's always funny how images from these sorts of reports are always just a little bit blurry or out of focus."
Well, this is one of the classic ones of a sighting of a Bigfoot, because it's a video that runs for about 14 minutes and nothing happens. So it's one of those things, it was over there and you can't see it, or it was over there and it's not filmed, etc. And you wonder why the hell would you be posting a lengthy video as proof of your saw Bigfoot when there's nothing there. There's nothing on the film, and there's only voices of the other sort of people wandering around.
Hey, Discovery made an entire series about it. It's called Finding Bigfoot.
Discovery will make an entire series about lots of things, unfortunately. But I mean, there's funny voices and static on some electronic equipment, and as we know, static on electronic equipment is nothing particularly sort of clever. And there's other people saying, "What was it? What happened?" And someone says, "Did you see that?" And I said, "No." And so it's basically, I only included this because it is such an annoying video and that it really says nothing at all about what's going on. And I decided to publish this information so it'd stop anyone else from having to watch it and spend 14 minutes.
So you don't have to.
Yeah, that's basically it, yeah.
And of course, the problem is it's all done with this British accent because this is set in the UK somewhere. And we all know that Sasquatches exist in North America.
And South America.
And South America. Oh, really? I didn't know they go there.
And Singapore, believe it or not.
Oh, that's right. There's a dude in Singapore as well, isn't there?
Yeah, this tiny little park. That sort of well-travelled, well-marked pathway through this park apparently has a Bigfoot-style creature.
And, of course, the Himalayas, where it all started.
And, of course, the Himalayas. In fact, there's hardly a country around that doesn't have a Bigfoot, mate.
Most of them work as bouncers.
But anyway, this was a story that was sort of supposedly proof of Bigfoot, 14 minutes of showing absolutely nothing. And you think, that's carrying Bigfoot research and Bigfoot aficionados too far, I think, to actually push me on that one. So let's show some more men dressed in suits like the Patterson Bigfoot video in America, which was pretty obviously someone in a suit.
And which they later admitted was a fake, and they still use it as the example.
Well, the famous Loch Ness Monster photos, the surgeon's photo, which is the most famous Loch Ness, is a fake, admitted to be a fake. It was an obvious fake to start with, really, for various reasons. But they seem to admit it was a fake, but it's still thrown up there as evidence of Loch Ness Monsters.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTimeWithStuartGary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.